generated not by organizations or professional authors, but by ordinary users. And some recent surveys found that from the overall internet population, only 27% of the users are English speaking. So we have this huge amount of content which is created in a variety of languages, and not most of it is in English. And currently, most of this content remains untranslated. So there's an opportunity here. If we are able to use machine translation to translate some of this content, this enables penetration into markets which are currently underexploited or unexploited. So translating user-generated content as is problematic for machine translation. There are mainly two large problems. The first of them is that we could consider that the content has low quality. We can categorize the source of the errors that the content usually has in three ways. So the first is where content was created by non-native speakers. So in this case, we usually see grammatical errors or morphological errors. The second category is where the users are native speakers or are competent in the language, but they have involuntarily introduced errors simply because they are typing too fast or because the context is informal, so there's no motivation to fix the errors. And the third category is where users have deliberately introduced errors to bring some linguistic effect. So this is the case of abbreviations like LOL, or using special symbols or character or numbers instead of normal letters. The second big challenge that we face is that typically there's no parallel data available. So since this content remains mostly untranslated, there's no gold standard that we can use to train statistical machine translation engines. So I'll now briefly introduce SmartMate, which is where the framework where we host our machine translation engines. We presented this on the LRC last year, so some of you might be familiar with it. And in a nutshell, SmartMate, it's a self-service translation platform which enables both individuals and organizations to introduce customized machine translation into their workflows. So the idea is that we have this nice user interface which is intuitive to use, and you can just log in, you upload your parallel data like DMX files, and from your data you can, just by pressing a few buttons, automatically create your own personalized machine translation engine. You can then upload the content that you want to translate and you're ready to go. So the main components in SmartMate are firstly machine translation. This is powered by the Moses translation toolkit, and our engines are able to handle encoding conversion. They do all sorts of cleaning to the input documents. We can correctly handle markup and formatting tags, and so on. An important feature is that we can handle glossary injection. So if you have a client-specific terminology, you can choose to make the engines adhere to this terminology. So whenever a source term is found in the a source term from the glossary is found in an input document, the translation stipulated by the glossary will always be used in the machine translation output. Well, most SmartMate is cloud-based, which means that this is scalable and it can be used online. And in addition to machine translation, we have all the typical components that you would expect in a workflow, like translation memory, file filtering. We have a web-based user interface which has an online editor which integrates all of these components. So you can do the end-to-end translation process without requiring any external tool. But if you don't like this and you have your own tool that you prefer to use, we also provide a set of APIs which you can use to integrate any of these components into your own software. So I'll now describe a very small, well, not small, but a project that is on its very early stages. And this is work that we have done for a large online games developer. So this is the kind of games that you would see in social networks. In this project, ALS handles translation memory, machine translation, and the actual translations. And quality assurance and proofreading is outsourced to a third party. So games get localized into 15 languages, and they are published to an audience of 180 million users. The whole process is fully integrated and supported by SmartMate. But as I said, this project is still on its early stages. We are still not using machine translation. We are only using translation memory. So the idea is that over time, the translation memories will have a sufficiently large size, which will enable us to create a customer-specific machine translation engine. But why is this project interesting? So the thing is that games are written originally in English, but some of the content itself, it's actually written by the developers. And the developers are not native English speakers. They are mostly from China and some other parts of Asia. So the source English is of bad quality. So before we can even think about localizing this into 15 languages, we need to fix the source. So this company has been for a time correcting the bad English into good English, and over time this creates a collection of bad English and corrected English, and we can consider this as a parallel corpus that we can use to create a machine translation engine which will translate from bad English into good English. But as I said, we haven't reached that stage yet, so this is a bit of future work, but this is an example of how we can handle the first category of errors that I mentioned, where the authors are non-native speakers. The next study that I will show, it's about a project that is more mature, and it's about the second two categories that I mentioned. It's when the content is written by native speakers, but they make deliberately or indeliberately they introduce errors. So this is work that we have done for Dudu. Dudu is the world's first multilingual social network. The idea is that users can interact with each other in the available languages in the system. So a user will type a post in his language, and another user who speaks some other language will automatically see the translation in his language. So machine translation is at the core of the business model of this web page. The core of the company is based on the United Arab Emirates. So the languages that they deal the most with are the languages of this region. So far we have implemented machine translation between English, Russian, Arabic, and Turkish. And we have implemented all possible combinations between these four language pairs, these languages. So we have deployed 12 language pairs, 12 different machine translation engines. So the first challenge that we faced with the Dudu case is that they had no parallel data at all. So we had nothing to train our engines with, so we had to find ways in which we could source this data ourselves. They did, however, have large quantity of monolingual data. So this was really beneficial because we were able to use this monolingual data to train language models, which make the engines produce output which is similar to the style that you will find normally in this web page. But this is only monolingual data. We also need parallel data. So what we did was to use subtitle data from the Opus corpus. And the reason for this is that subtitles share some linguistic characteristics with the kind of content that we are translating. And they are also constrained by length, as is the content we are translating. Since we had no in-domain parallel data, we had to find a way of creating a development and test sets which we could use to tune and evaluate our engines. So what we did was to use these in-domain language models that we created with UDO data, and we used this to find the sentence pairs in the subtitle data, which was most similar to the content that we were going to be translating. So this way, we didn't have a real in-domain test set and development set, but from the data available, we had created the ones that are more similar to what we will be translating. In addition to this, we also created language models using data obtained from Twitter. This also, since it's really similar to the content that we are translating, this helped improve translation quality scores a lot. And finally, we also obtained large dictionaries of internet slang, and we manually translated these dictionaries into all the available languages. So this created a multilingual dictionary, which helped reduce a lot the out-of-vocabulary words for terminology that is used in this kind of content. So having obtained all this data, we turned into investigating which ways in which we could extend and improve our preprocessing routines so that we can handle errors of this particular content. So in addition to the usual cleaning pipeline that we do, which includes correcting encoding and formatting tags and so on, we also looked into using spell checkers, which are based on the edit distance. So the idea is that when an input sentence that we want to translate has a word that we haven't seen during training on the training corpus, we can map it to the closest word using these spell checkers. But in some cases, the differences between the misspelled version and the correct spelling were too large to be captured by the edit distance. So in these cases, what we are investigating is using a soundex algorithm. So using this algorithm, you can obtain a phonetic representation of a word. So words that sound similar but are spelled differently will be assigned the same soundex code, like the examples in these tables. Each row, the spellings are different, but the soundex code that they get assigned are the same. So some results. I know some people don't like blue scores, but it's at the moment what we have obtained. And this does give us an indication of the quality that we can expect from these engines. So in this case, the baselines are the first systems that we built as soon as we obtain the parallel data, and the improved ones are the ones that we obtain after throwing in all these additional resources like the in-domain language models, tutor data, multilingual dictionaries, and so on. So we were able to obtain really large translation quality improvements. This is an overview of the final scores that we obtained for all of the engines. There are a lot of numbers there. I don't expect you to read all of them and interpret all of them, but I think the main conclusion is that the engine seems to be doing a really good job. Scores are quite high. The most difficult language pair seems to be Arabic to and from Turkish, but English to and from Russian, and Russian to and from Turkish seem to perform really, really well. In addition to the automatic scores, we also did a couple of rounds of feedback with Dudu. So we asked them to provide us with suggestions in ways in which we could improve the engines, and also they could provide us with post-edited data. So they ran the machine translation engines through some of the posts, and from the output they corrected it with to what they would have expected. So regarding the suggestions that they gave us, most of the feedback was about wrong lexical choice. A rather amusing example was that the engine was systematically translating the word nice into the Russian form of the city Nice, France. So we were able to fix this kind of error for them. And using the post-edit data that they gave us, this was also really helpful. We exploited that in two ways. Firstly, from the corrections that were short, we were able to obtain regular expressions. And using these regular expressions, we modified the training corpus, the parallel data, so that after retraining the engines will have learned from the suggestions that they gave us. And in addition to that, we added all the post-edited data. We appended that to the training corpus, and this gave us some further improvements. So some statistics about the volume that we are translating for them. So this is always online translation. So it has some speed requirements. To be able to meet these speed demands, we statistically prune the engines so that they are of a smaller size, but they have very little degradation of translation quality, but speed is greatly improved. So Dudu connects with SmartMate through our REST-based API, and in the last 7 months, they have translated 135 million words. And this includes the first month where we were just ramping up. So near the end, so to summarize the talk, I presented an overview of some of the technology that ALS have been developing for dealing with user-generated content. And I presented some use case where this was applied. In particular, for the Dudu project, this is live and being heavily used for 12 language pairs. And we have shown how using domain adaptation techniques, like trying to come up with the best development sets, and being smart in the way in which we obtain additional data, and improving our preprocessing and cleaning routines to cope with this kind of content, we can obtain high-quality machine translation for user-generated content. So there's still a lot of areas in which we can further improve this, and we are actively working on this. The first of which is that all of the languages that we are dealing with, except English, are morphologically rich. So there's work that we can do there to improve the machine translation quality using stemmers and part-of-speech taggers and so on. We are also looking into using regular expressions to handle wordplay, like this example there, cool, where additional letters were introduced. We are also looking into using named entities handling so that things like company names are not translated or left as is when that should happen. And a related task is detecting foreign expressions which shouldn't be translated because they are intentionally left that way, like al dente. Finally, so well, most of the things that I've been talking to were developed exclusively for these clients. When an improvement is general enough so that most users will benefit from it, we fit that back into standard SmartMate. So if you would like to try some of this out, everybody's free to join for a 30-day trial at smartmate.co.
Thanks very much, Sergio. And we have some time for questions. Anybody want to start? Can I ask, in the games application, you do sort of improvement of English by non-native speakers into sort of more standard English. Does it depend upon their sort of source culture, so to speak? So do Chinese people make different mistakes?
Well, the problem is that these are not Chinese linguists that are creating the content, but Chinese developers. So it's really bad quality English.
It's Chinese plus nerd culture.
Something like that. The company called it Chinglish.
I have a question. I'm curious about where did you get the slang dictionaries? Any known sources?
It's not a free source, if that's what you're interested in.
Yeah, I was curious.
We had to buy it. I really been able to tell you right now where we got it from.
Sergio, could you explain a bit more what you mean by statistical pruning?
Yes, so the machine translation engines, one of the biggest modules within the system is a large database of phrase pairs. And these are, the way they are obtained is automatic, and there are things there which are usually not really needed. They are just there because of the way the system is created. And there are errors, there are very long tail cases. So statistical pruning, what it means is finding out which of these phrase pairs are more relevant and which ones are most likely to be used. So using this, you can discard some of these phrase pairs, and you can do things like discard 90% of the collected phrase pairs, and the reduction in translation quality, or at least blue scores, is minimal. In some cases, it's even you even get an improvement